All right, colored pens up. So, question number 1 is the second time we're seeing this style of question, but it was not part of any formal lesson that I did. It was more of a mini lesson I did at the beginning of last class. Then 2 through 9 are all review questions as we're heading towards the end of the chapter. So let's see how we did with number 1. What did you get? We'll start with Isabella, then Rashida, and then Chanel.
4.5 cups.
Okay. 56. Okay. Chanel? Okay, wasn't an optional question, so you got to be careful. If you don't know how to do something, then I should see one of a number of behaviors. You could ask your neighbor and say, how did you start the question? Ask the person in front of you, the person diagonal from you. Or your hand goes up, you give me the sign for help, and I come over and help you. One of the options is never, I just didn't do it. That's not one of the options. Okay, so we have 2 different answers out there. I need someone else. Michael, Joali, and then Kivon. Okay? The correct answer is 4.5 cups. 4.5 cups. Number 2. Now we're into reviewing concepts that we spent quite a bit of time on. Number 2, what did we get? Just 2 confident people, 3 confident people, 5, 6 confident people. We'll start with Ezekiel, Mia, and then Valerie.
-5.
5.
So we have a disagreement. -5, 5, and they agree with each other. What do you think, Alex? 5. The correct answer is -5. Number 3, what did we get? We'll start with Danae, then Yadesh, and then Garion.
110.
110.
The correct answer is 110. Now we get into basic, rote, simple calculations that you should be able to do very quickly at this point. Number 4, what did we get? Briante and then Michaela.
12.
The correct answer is 12. Number 5, what did we get? We got Isabella and then Selena.
-42.
That is correct. It is -42. Number 6, what did we get? Yadesh and then Kivon. We get -9. And what about number 7? What do we get there? We'll start with Michaela and then we'll go to Kivon. Oh, we have a big disagreement. What do you think, Michael? The correct answer is -36. Number 8. We will start with Mia, then we'll go to Rashida, and then Christopher. I'm sorry? Okay. Big disagreement. The correct answer is 24. Number 9. What do we get? We'll start with Michael, Ezekiel, and then Yadesh. Okay?
I didn't get to the 9.
Okay?
0.
The correct answer is 0. So now I'm going to open up the floor for questions, starting with this bottom set of questions first. Anything from 2 through 9. We'll start with Selena.
No.
Number 9? Good. So, we have 2 operations, subtraction and subtraction. Which one are we supposed to do first? Only 2 people know, but we spent some time on this. Chanel? The first one. So now let me change my highlights so you can focus This is what you have to do first. Now, here's the next piece. What rule or magic phrase do we use to help ourselves with this? Briante? Keep, change, change. And so we are going to keep, change, keep, change, change. And so now we have 12 plus 1. This value is now 13. Now bring down the part that we haven't used yet, minus 13. And now you can clearly see that 13 minus 13 is 0. Did you find your mistake? Okay, what?
I had added the 13.
So you actually got 13 initially, and then you just accidentally added them? Okay, good. Well, you did the hard part. Good job. Okay, and thank you for sharing your mistake. Other questions from 2 through 9? Nope. Other questions? Okay, let's go to number 1 where we had some disagreement. Give me a thumbs up if you got number 1 correct. Good. Danae, start us off. How did you do it?
I added 3.5. I added 3.5 and then multiplied it times 3 to get 21.
Okay, so you added 3.5 plus 3.5, and what did you get?
7.
Okay, so you did 3.5 plus 3.5, which got you 7, and then you multiplied that times 3, and that got you the 21. Okay, what'd you do from there?
And then here's the 3/4. I added the 3/4 because you added it again. And then I multiplied times 3 and 1.
So you followed the same rule that you established here. The rule you established was add itself and then multiply by 3. So that's what you did again. Very interesting approach. So you added itself, you added 3/4, which got you 1.5 or 1.5, and then you multiplied that times 3, and you got 4.5. Very interesting approach. Very nice job using logic to work your way through. Joali and then Caesar. Joali, what did you do?
Well, I multiplied 3.5 times 6, and I did it again.
Okay. How did you know it was times 6?
Well, I divided 21 times, divided by 3.5.
Okay, so you actually took 21, divided by 3.5, and you figured out that that was 6. And so what he'd established now is that 6 is the multiplier that Quentin is using to multiply his recipe, which is basically what Danae did. Danae just took a different route to do it. Multiply this by 6, which means you have to multiply every other ingredient times 6. If you don't multiply every ingredient by the same multiplier, your recipe will get all messed up and it won't taste correct. So once he established it was times 6, I asked about the chopped nuts. So he did 3/4 times 6, which gets you 4.5. Very good. Caesar?
I did 3.5 plus 3.5 plus 3.5 plus 3.5 plus 3.5 plus 3.5.
Very good.
And I got
And so how many 3.5s were there?
6.
6. Excellent job.
3.5 to the 6th power equals 21. So then I added.
Well, 3.5 to the 6th power does not equal 21.
No, I meant like to myself, like there's 6, 3.5.
Oh, okay. I follow.
So then I added 3/4 repeatedly, and then I got 18/4. So then I just did the stuff that you did.
Very good. So you actually did 3/4 plus 3/4, and you did it 6 times, right?
Yeah.
Excellent job. So a totally different approach, but you get the same result, and in actuality, it's a very similar approach. You're just basically doing multiplication the long way, but it made sense to you, and that's the most important thing. Okay? And you said it was 18/4?
Yeah.
Very good. And 18/4 is another way of saying 4.5. Excellent job. So we got 3 different approaches from 3 different people. Any comments or questions? Comments or questions on any of these? Okay? Put the warm-up to the... Today we're going to be exploring the concept of the coordinate plane. I am approaching this as if it's somewhat of a review for you, but I'm going to go a little bit slowly at times to make sure we're understanding and we recall how the system works. Before we do, I want to talk about this system called the coordinate plane. So I have a couple of survey questions for you. Give me a thumbs up if you know what a GPS is. Give me a thumbs up if you know what a GPS is. Almost everybody has their thumb up. Good, put your thumbs down. Give me a thumbs up if you know what GPS stands for. Okay? What does it stand for? Okay. What does it stand for?
Global graphing.
GP.
Oh.
All right, he's got the first word, global. Anyone want to finish it off? What does it stand for?
Global positioning system.
Very good. Global positioning system. Okay? Global positioning system. Does anyone know how it works? Give me a thumbs up if you know how it works. How does it work?
Okay. You put in the address. Okay. Put in the address and then your destination, and then like this annoying lady starts talking, and then and then you get the card thing, and it tells you go left and go right, and then. If you
How do you know that the annoying lady's not my mother?
What?
Wouldn't I be insulted by that?
What? She's annoying. She's not
So
annoying.
you're calling my mother annoying? That's rude. Okay, it's not my mother, I'm just joking. Okay, so yes, the annoying lady comes on and tells you where to go. Okay, but that's not how it works. That's what we get from it. We get the directions, we get the magic. But how does it work? Michaela?
Like you type in where you are, and then it like goes to some satellite.
Okay, so there are satellites involved. Where are the satellites?
Space.
Where are they, Danae? Okay, so there's actually a system called triangulation, and there's really complex stuff going on when we talk about a GPS. Very complex. However, the basics is this. The entire globe is one giant coordinate plane. For you to understand how our world works at this level of technology, you must understand what I'm going to be demonstrating and working with you today. The coordinate plane. So, we're going to start with just a plain old piece of graph paper, and I've given it to you. Okay? So you're going to add some things to this. I actually already have the first couple of pieces on there for you. We take this piece of graph paper, and we basically cover the world with it. That's what has happened with global positioning systems and all sorts of different technology. And then what we do, and what scientists do, is we add things to it. So we add this. Does anyone know what this is called? What is that called? Isabella?
The x-axis.
That is called technically the x-axis or the horizontal axis. Now, this helps us find a location, and let me show you how. If this is 0 right here, so I'm going to put a little blue dot right here just temporarily. If that's 0, then what would this position be right there where I have my pen? What would that position be? Valerie? 1. Very good. Now here's the big question. What would this position be right there where I have my pen now? We got a whole lot of people who know. Alex? -1. What would this, and I'm going to count, listen to me count. 1, 2, 3, 4, 5, 6. What would that position be called right there? Chanel? -6. So if we go to the right, all the numbers are, and if we go to the left? Negative. Very good. So now we take that system that we already know and add to it. We add a second piece. Here's the second piece. What is this called? Rashida? The y-axis, also known as the vertical axis. And really, it's a little bit hard to tell, but really what I did was I took the x-axis, and all I did was I rotated it. So imagine, watch what happens. If I rotate this, okay, where are the positives? Are the positives up here or are they down here? Where are the positives? Selena? Yeah. So watch what happens to my positives as I turn this. Where do the positives end up? Briante? On the y-axis going up or down? Up. So where are the negatives now? Where are the negatives, Danae? Going down. And so what we end up having, and let me put this back, is we end up having 2 positives and 2 negatives. This is positive, and the y-axis, this is positive. On the x-axis, this is negative, and on the y-axis, this is negative. When we put all this together, we have actually now formed a system. Any questions so far? So those parts are already on your paper. I did that for you. Now you're going to have to add in. So when we do this, it actually makes a system, and here's part of the system. The origin is our starting point. So Selena referred to the annoying lady who comes on the GPS and tells you where to go. But before the annoying lady comes on and tells you where to go, you have to type in where you are. Or actually, at this point, with technology, it already knows where you are. But it needs a starting point. The origin for us is always our starting point. We always come back to this location right here, 0, 0. Any questions about that? Also part of the system is this. The system has been divided into 4 separate areas called quadrants. Anyone know what the prefix quad means? Without yelling out, raise your hand. Mia? 4. Quad means 4. So quadrant is one of 4 sections. And they have names. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. You actually have to commit to memory which one is which. It is not easy to commit it to memory, so you're going to have to use something to help yourself. I'm going to offer this advanced class a very fancy word, and my hope is because it's a high-level fancy word, you might actually remember it. The fancy word is counterclockwise. Counterclockwise. So let me explain the word, and then I'll explain how it applies. Everyone look at my clock over here. Look at the red second hand. It is moving this way. That's called clockwise. Clockwise means it moves towards the right. Counterclockwise would mean the opposite direction. So look where quadrant 1 is. Quadrant 1 is always the upper right-hand corner, and everything moves in a counterclockwise direction from here down this way. So you actually have to remember, because I'm going to ask you questions like, in which quadrant is this point? Or in the world of a GPS, in which quadrant is the car? The car could be in quadrant 1, 2, 3, or 4. Does anyone have any questions so far? Okay, now here's the big piece. Now we have the system set up, and now we can locate any point, any position, anywhere on this grid. And here's what it looks like. Here is a point. In the world of GPS, that would be the car. And so the satellite up in space is viewing your car as like a little dot. And it knows the position. In our world, the position is labeled like this. We use two numbers. The first number is the position on the x-axis. So I got the -5 because I went 1, 2, 3, 4, 5 to the left. I got the +4 because then I went up 1, 2, 3, 4 up. And so with those two numbers, we can establish an exact position. And so every lattice point, every point anywhere on this grid, they're called lattice points. You don't have to remember that right now. Any position can be identified with two numbers, the x-coordinate and the y-coordinate. And we're going to use this system today. We're actually going to build on this in a little while. Does anyone have any questions so far? Give me a thumbs up if you're feeling comfortable with this system. Okay, if you're not. Good, put your thumbs down. Okay, so hopefully we'll become more comfortable. Example 1. Now let's actually put it into practice and see how the system works. Everyone, on your worksheet above the graph over here, write example 1. That's where we're going to do example 1. So, first we're going to be given a position. So now it's like we're the satellite looking down on the cars. Okay? We're the satellite, and we're looking down at the car, and I, as the satellite, have to know where that car is. So I need to be able to say the two coordinates, the x-coordinate and the y-coordinate, for that point. Now, the satellite's a computer system, so it knows it instantly. But we have to do a tiny bit of work. Really, it's not very difficult. And so we need to move from the origin to that point. We always move left and right first. The analogy that I use, and maybe you've heard in the past, is walking to an elevator and then taking the elevator up and down. You would have to walk to the elevator before you could take it up or down. So we walk left and right, then we take the elevator up or down. So from the origin, to get to point A, where are we going to go? To the right or to the left? To the right or to the left? Isabella?
We're going to go to the right.
Good. So we're going to walk 1, 2, 3, 4 to the right. Is 4 to the right positive or is that negative? Yadesh? Positive. So our x-coordinate for point A is +4. Now we're at the elevator. Now we're going to take the elevator up or down. Which way are we going to go to get to point A? Ezekiel? Up. So we're going to go up. 1, 2, 3, 4. And so going up is positive or is that negative? Michaela? Positive. So the coordinates are 4, 4, and that's the location of point A. So I, as the satellite, have now identified the location of the car. I also want to know its general location. So it says give the location. This is a specific point, but I want its general location. And so now we're going to identify its quadrant. What quadrant is it in? Rashida? So we're going to write Q and Roman numeral 1. I don't need you to write quadrant 1. I know that Q1 is quadrant 1. We use Roman numerals, though. Does anyone have any questions? Okay, so now look at my score scale over here. Give me a thumbs up if you feel like you're a level 8 or 9 with this idea so far. Level 8 or 9. Good, put your thumbs down. So I'm going to skip over a couple of them. I want to skip over B. I want to go to C, because this is a kind of thing that messes up even very bright students and adults. So let's identify the position of point C. Remember, we walked to the elevator first. So Michael, where are we going to go? To the left, 4. 1, 2, 3, 4. And I heard you say that that's what? Negative 4. Moving to the left is negative. So that's negative 4. Here's the part that's tricky. We're going to take the elevator up or down. Where are we going to take it? Where are we going to take it? Kevon? Nowhere. So if I take the elevator nowhere, Mia, how many floors have I moved? Okay, and what math term or number can we apply to that? 0. We've moved 0 floors, so that's negative 4 comma 0. Now I want its general location, so I want its quadrant. So we're going to put a semicolon. What quadrant is point C in? Briante and then Ezekiel. Quadrant 2. What were you going to say? Quadrant 3. So she says quadrant 2, quadrant 3. Danae?
Quadrant 2.
You think quadrant 2? What do you think?
It's not in a
Not in a quadrant, so that's something new. Well, I kind of agree with everybody. It's in quadrant 2 partially. The top half is. The bottom half is in quadrant 3. So Isabella's kind of got the compromise. It's not in a quadrant. So if a point is not in a quadrant but it's on an axis, we don't say a quadrant. We write the axis that it's on. So this is on which axis? Which axis is this point on? Alex?
The X.
So instead of writing a quadrant, we will write x-axis. Does anyone have any questions on the system so far? So this example was from the perspective of the satellite. Now you have a third grid, bottom left. It's blank. Example 2 is going to be done there, so everyone write example 2. Now we're operating from the perspective of the car. Now I'm in the car, and like Selena described, you punch in an address. So now what I am telling my satellite partner is I'm telling the satellite, I want to go to this address. Where is it? Okay? So we want to identify where S is. So we start at the origin, and now instead of counting, we're going to actually move that number of steps. So the first number, -5, what does that tell us to do? Caesar? Okay, I'll come back to you for the next one. Ezekiel? To the left, how many steps? 5. So we're going to go 1, 2, 3, 4, 5, and now I'm at the elevator. Caesar, the second number tells us to do what?
Go up
How many?
7 boxes.
So we're going to go up. 1, 2, 3, 4, 5, 6, 7. We're going to put a nice clear point on that lattice point, and we're going to label it. This is S. It's -5, comma 7. And we want to know its general location, and so what is its quadrant? What is its quadrant? Chanel? Very good. Try to do the quadrants without looking from now on to see if you can start committing it to memory. I think many of you are doing that already. So we have now told the satellite where we want to go. Any questions on how we did that? Okay. What about T? Now I'm telling the satellite I want to go somewhere different. So we want to identify to the satellite this location T. The first number, the 0, what does that tell us to do? Michael? Say that a little louder so Caesar and Kevon can hear you. Very good. That was exactly the way I would have said it. It tells us to stay right there. And then Briante, the second number, tells us to do what? Very good. 1, 2, 3, 4, 5, 6. I put this example on here on purpose because I cannot tell you how many times I see students put this point over here. 1, 2, 3, 4, 5, 6, right there. Because I have a lot of students who say, oh, 0, don't do anything, now move over 6. But the first number always means the x, and the second number always means the y. So you can't take the numbers and use them for a different axis. All right, so now what is the quadrant of point T? What's the quadrant? Selena?
Quadrant 1.
Quadrant 1. Mia?
Oh, yeah.
Okay. You see? Okay. So it is the y-axis. Very good. And Selena now sees her tiny little mistake. Does anyone have any questions on how we identify or how we find these locations? Okay, give me a thumbs up if you are feeling level 8 or level 9 on this part of it. Good. Put your thumbs down. So we're just going to move forward. Not necessary to go any further. But here is what we've been building to. So you are going to have to use your loose leaf paper and your worksheet at the same time. So everyone write example 3. And what we're going to do now is use this system to actually explore some scientific data. So on your notebook paper, you're going to write example 3. You don't have to write the scenario, but you need to read it. But we need the table of data. So I'm going to give you a moment to copy down the table of data. It's a very simple horizontal table. Don't make it too complicated. So here's the scenario, and you're going to, over the course of this year, be exposed to doing some scientific experiments and mathematical type experiments. So if we keep track of how many hours we study, and then we look at the performance on the test for which we were studying, we want to see, is there some trend? Is there something going on based on the information I've collected? So anyone have any thoughts just by looking at the data in a table format? Sheeta?
The more hours he or she studies, the better score they get.
Okay, that was a pretty well thought out statement you made. I really like that. So what we're going to do now is make a picture out of the data and see if what she's saying is actually true. Okay? So we're going to make what is called a scatter plot, and now you need the fourth. Right, we're on to the fourth one?
Yes.
The fourth grid. You're going to notice something different about it. Someone tell us what's different about it? What is different about it, Caesar?
There is no quadrant 2, 3, or 4.
You said that in a really advanced, specific way, and I really, really like that. So which quadrant are we looking at?
1.
Very good. Could someone explain why I only need quadrant 1? Why do we only need quadrant 1? Kevon?
All the numbers are positive.
You said that perfectly. All the numbers are positive. If I had any negative numbers in my data, then I would need quadrants 2, 3, and 4. But if all the numbers are positive, then I don't need those quadrants because there will be no points anywhere, and it's a waste of space. So Caesar and Kevon, perfectly described. Excellent. So, part A, draw a scatter plot of the data. When you draw a graph, you have to plan it. I'm not talking about planning something for an hour. I'm talking taking 30 seconds to think about it before you actually start drawing it. One of these pieces of data is our x-axis, and one of them is our y. Does anyone know which one has to be the x? Selena?
The bottom one,
The bottom one, what were you going to say, Isabella?
the hour studying.
So you disagree. The hours, you say the top? The bottom is the score.
Oh, no, the hour studying.
Okay, because I thought that's what you said, the hour study. But you're saying the bottom, the score?
No, the hour studying would be on the x-axis.
Oh, okay. So I'm asking, which of these? Hours studying or score? Which one goes on the x-axis?
Hour studying.
Oh, okay, so you guys agree with each other. And yes, they are correct. This is the x, and this is the y. In science class, I believe you worked on this recently. Does anyone remember the name of the x? What is it in the world of science? She gave you a pretty fancy word. Michaela? Very good. That's called the independent variable. It's the initial information we need to determine the second piece. The y is called the dependent. It depends on this. So they explained it perfectly. This is going on the x-axis, so we need to plan it out. All the numbers are really small, so we don't really have to worry about the x-axis. We can just go by ones. So we're going to go 0, 1, 2, 3, 4, 5, 6, and I think 5 was the biggest number, so we don't really need to go too crazy. As long as the interval is the same, then we're okay. And the x-axis is the hours of study. Now the y-axis, we have a different situation. The y-axis, we have much larger numbers. If I go by ones, excuse me, if I go by ones, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I won't get up to 55. I certainly won't get up to 98. So what am I going to do to make sure this data fits? Yadesh? Go by tens? What were you going to say? You agree? Go by tens? Yeah, that's one of our best choices. We have other choices, but that's a good one. Let's see if it will fit. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It will fit perfectly. So we're going to do that. 0, 10, Now, how do we get from the table to the graph? Because that's like, where does the 1 go and where does the 2 with the 3 go? Like, where do they go? So the part that maybe you already knew, but maybe you didn't realize was that each pair of numbers is actually an ordered pair. This actually means 1, 55. This actually means 3, 78. And so on with all of them. And so now we actually have 5 ordered pairs that we can plot on our graph. And that's where our picture is going to come from. Does anyone have any questions on how that happened? So that's what we're going to do. And now we just need 5 dots that we need to draw out. 155. And you want to try and be accurate as you can be. The 55 is going to be halfway between the 50 and the 60. Make a nice clear dot right there. 378. Make sure you go to the 3 and then go up to 78. Well, that's a little bit harder. It's going to be below the 80 by a little bit. 4, 86. 4, 85's halfway, so 86 will be a little bit above that. 489. 489 is going to be right below the 90. And then 598. 98 is going to be just below the 100. So that's a good question that someone sort of asked. They didn't really ask, but I heard them say it. So where's the 2? Well, you got to remember is that this is a person who's keeping track of their studying habits. So on the first test, they studied for an hour. The second test, they studied for 3 hours. There was no test where they studied for 2. So there is no 2 comma anything. But I want you to watch, and this is the power of a graph. I do not want you to draw a line, but I want you to watch what I do. Don't draw a line, but watch mine. If the person studied for 2 hours, what do you think their score would be? If they studied for 2 hours, Ezekiel, what do you think their score would be?
Like a 67.
A 67. So he's looking, hopefully, right about there. And I'd say that's about a 65, 66, 67 could be. I mean, you don't know. But that's a good prediction of how the person is doing. So that's one of the powers of the graph is it then gives you predictive abilities. You can now make predictions of things. Okay? Very good. Now, you are not going to draw a line. We're going to leave it like this. And now we want to identify the relationship that we see. Excuse me. When your data is moving up and to the right, does anyone know what it's called? Go ahead. Well, it is a scatter plot graph, but now we want to identify the trend.
Oh, a line graph?
Okay, so it looks like it's going to be a line. What were you going to say? Okay, well, there's a word that we need to add in, and it's positive. If the data moves up and to the right, that is called a positive relationship. And it basically sums up what Rashida said at the beginning. The more hours you study, the higher your grade will be. As the hours goes up, the scores go up. But let's explore a different scenario. What if we track how many hours you played your Xbox and then the score of your test the next day? So let's say you played an hour of Xbox and then the next day you take a test and you get a 60. And then next week you play your Xbox for 2 hours, then take the test the next day and you get a 50. And then the week after that you play your Xbox for 4 hours, then you take a test and you get a 30. The more hours you play, what's happening to your score? Down. That's called a negative relationship. As one number goes up, the other one goes down. And I didn't finish the word. Relationship. Okay? Positive relationship. Okay? So does anyone have any questions on how we converted the data into points, how we plotted the points, how we constructed the graph? Any questions? Good. Draw a line across your paper. Your classwork is in the textbook. You're going to do page 49. Numbers 12, 13, 14, and 15. Then numbers 27 and 29. Make sure you do the correct questions. For some reason, I've had a few people do the wrong ones. 27, we're not doing 28, and then you are doing number 29. Okay? Got about 15 minutes of independent work time. I'll be circulating to assist and guide. The first 4 questions you should finish in a matter of 30 seconds to a minute. Most of your time is going to be spent on numbers 27 and 29. And the back of your worksheet has grids for you to use. They don't necessarily go in order. Use whichever ones you want to use. You choose which ones you want to use, okay? If you're confused, just raise your hand and I will help you. All right, let's see how we did with the coordinate plane. Pick up your colored pen. The first 4 questions everybody should have gotten. But if you made a mistake, it's okay. Doesn't make you a bad person. But we have to make sure we're understanding how the system works. 12, 13, 14, 15. Number 27. There were 2 parts. Part A was to draw a scatter plot. So your scatter plot should look similar. Doesn't have to be exact, but it should look pretty similar. Especially considering I gave you a perfect grid to use, shouldn't have been that difficult. Part B, the publisher provided us with a very elaborate explanation. I was really looking for positive relationship or negative relationship or no relationship. So it should be a positive relationship because it's moving up and to the right. So that's a positive relationship. And I'll answer questions in a moment. And then the last one was a different style of question. You were asked to plot 4 points. Then it told you what order to connect them. And then you were asked in part B to identify the figure. What figure is it? Isabella? Okay, well, it looks like a square. I think maybe it's a square. How can we prove that it's a square? Michael? Does it? That was a great statement that you made. Okay, let's check. 1, 2, 3, 4, 5, 6, 7, 8. So this side is 8 units. Now let's check the other side. 1, 2, 3, 4, 5, 6, 7, 8. Both sides are 8 units. That means this is a square. If one side was longer than the other, but it was right angles here and here and here and here, then it would be a rectangle. Okay? Very good. Excellent explanation. So part B was square. All right, comments and questions on anything. Caesar, you were first.
For 27, I put there is an increase.
Okay, well, I was looking for positive relationship or negative relationship. So give yourself half, because you said something that sounds like positive, but I'm looking for positive or negative. Yes, Rashida.
So if you didn't put positive relationship, but you put something that's on the board, is that still happening?
Nope, you can mark it correct. Okay. Other questions or comments? Anything at all? Okay. Draw a line across your paper. Your homework. This is page 49, numbers 8 through 30. That's 12 questions. And your chapter 1 test is going to be on Friday. Our next class will be a review.